Hello, figure to show two charge Q1 and Q2 separate 4 cm apart at position P. Sketch electric field. So at the point P, you have two electric field. The first is come from the Q1 because Q1 is a positive charge, right? This is a positive charge. So direction of the electric field to the upward, and this is Q2 also positive. Okay, also positive. The direction is upwards electric field. So you have two electric field at the point P here. The first is come from the from the E2, and the second is a E1. So if you draw the diagram, the first you have the electric field from the E2, and the second is you have a E from Q1. And number 2, this be the resultant electric field, meaning you have the two electric field X on the point P here. So you must resolve E1, but the E1 is on the y-axis, so E2 you must resolve to the y-axis. So you have a triangle here. This is resolve E2 to the y, E2 y, and resolve E2 to the x. So this is E2 x. And the next you resolve E2 is only E1, but E1 on the y-axis, so E1 is equal to 0. So the E1 here is so that to calculate the E1 you must use the equation, okay, Q over this is Q1 over R square. So the K is constant, so 9 exponent 9, and the Q1 charge is 3.1 microcoulomb, and the distance here R from Q1 to the point P is 3, convert to the meter as 3 exponent minus 2. So the E1 is equal to 3.2 exponent 7 volt per meter. And the same process to calculate the E2. So the E2 you have a K Q2 over R square, and the K is constant 9 exponent 9, and the Q naught is charge Q naught is 4.8. This is minus 6. This is microcoulomb, and the distance from Q2 to the point P. So this is 4 cm, and this is 3 cm. This is 4 cm. So if you use the triangle here, this is 4, 3, and this is 5. So this is 5 convert to the meter is minus 2 square. So this is equal to 1.7 times 10 exponent 2 volt per meter per coulomb, right? So the E1 here is 3.2 exponent 7, and the E2 is equal to 1.7. This is 1.7 exponent 2, but E2 resolve to sorry, E2 resolve to the X, you must know the angle here. And the angle here, because the can use the okay, so this is E2 and the angle here is 37. This is E2x and this is E2y. So meaning this is resolved to the x, E2x, this is use cos 37 and y is 1.7 exponent exponent 2, right? I use this is sine 37 and you can calculate the EY and EX here. And next, if you calculate the net force, net E, so this is you have the two force here, maybe that this is E net on the point P, so E on the point P, you can use the equation EY square, so this is EY square plus EX square, so this is EX square. So you can use the value of EY and EX, so I just use the final answer. E at the point P is equal to 4.46 exponent 7 wood per meter. And to calculate the resultant, right? So this is an angle, so you can use tangent theta. Tangent theta is equal to EY, this is EY over EX. So you can find the theta is equal to 108 degree. Question number 3 is calculate electric potential. So as you know, electric potential is equation V is equal to Q over R. So you have the two charges here, so meaning electric potential at the point P, so you have the K is the Q1 over R, and the plus the second charge is a K Q2 over R. So the K is constant, 9 exponent 9. So Q1 is charge is 3.1, 3.2. This is minus 6. This is microcoulomb, and the Q2 is 4.8 microcoulomb, and distance point P to the Q1 is 3. Use meter is 3 minus 2, and from Q2 to the point P distance is this is 3, this is 4. You can use the triangle here. This is 5 cm, so meaning this is R here is 5 exponent 2, convert to the meter, this is centimeter. So the final answer for the V at the point P is 1.82 exponent 6 volt. And number B, that's mean the watt tons charged along the equipotential line. So according to the equation, the potential difference V is W over Q. So this is a potential difference, but if you calculate the watt ton, is delta V times Q at the, let's say they have a charge, positive charge, and this is the electric field E, and you have a, this is a dashed line, here is a equipotential surface. So meaning, let's say you have a point VA and you have the point VB at the same dashed line, meaning the potential at VA is equal potential at VB. So meaning at the equipotential line, VA is equal to VB. So meaning if you calculate the delta V here, delta V is a VA minus VB, but the same value of magnitude VA and VB, so this is equal to 0. That's why the work done is equal to 0. Thank you.